Hello everyone. In this video, we'll solve the booklet questions about heat transfer, and we'll start with paper 2 in the booklet. So in the first question, a metal rod is heated at end X. Why does end Y of the metal rod becomes hot? Since this rod is metal, so we have heat transfer by conduction, and this is due to the vibration of atoms or ions inside the rod, and also the transferring of electrons from one side to another. So we'll choose A. Energy is transferred from X to Y by vibration of positive ions and by movement of electrons, because we have both mechanisms, vibration and electron transfer. Option number 2, thermal energy is transferred by conduction in a metal. Which statement is not correct? Not correct. Fast vibrating ions leave the surface. No, in ions or in metal, sorry, we don't have ions that leave the surface. So we will choose A. And of course, all the other statements are correct. Free electrons, moving the free electrons carry thermal energy through the bar. Ions vibrate but don't change position, and so on. In question number 3, the diagram shows the view of a room heated by a radiator. The arrowed line from X to Y is the path of the convection current in the air, which row about the air temperature and the air density at X and Y is correct. Air temperature at X, of course, it's higher because it's near the radiator. And of course, the density of air at Y is higher also because the temperature is less, because this area is far from radiation. So the temperature is less than the temperature at X. So the temperature at X is high, and the density of air at Y is also high. So the temperature higher at X and the air density higher at Y. So we will choose B. In question number 4, scientists measured the air temperature at different heights from the floor in a cave. The results are recorded in the table. Why does altering the height affect the temperature of the air? Okay, as we see from the table, as the height increases, 10, 20, 30, and so on, the temperature of the air also increases. And this is because the molecule in warm air has less energy. This is a wrong statement, because in warm air, molecules have higher energy. The molecules in cool air are farther apart. No, in cool air, the molecules are close to each other. The warm air is less dense than cool air. This is a correct statement. Cool air rises. No. So we will choose C. Question number 5, the diagram shows 4 rods. Each rod is made of different metal, PQRS. Wax is used to attach a small metal ball at the end of P, Q, and S. So at each rod, we have metal ball. Okay, each rod, we have a metal ball. And this metal ball is stuck with the rod with wax. When we heat the 4 rods from the point X, as the rods warm up, the wax melts and the ball falls off. Why does the ball on the silver rod falls first? The ball on the silver rod falls first because silver is good conductor or best conductor of heat. So we'll choose A. The diagram shows a vacuum flask used to keep liquid warm. Which method of heat loss are reduced by vacuum between the silvered wall? Between the silvered wall, here we have a vacuum, okay? And the only process of heat transfer that occurs in vacuum is radiation. So the heat reduced by the vacuum, reduced by the process of convection and conduction. Vacuum can prevent or reduce conduction because the two silver wall not in contact with each other, and also convection because there is no air between them. So conduction and the convection prevented by vacuum. In question number 7, why are metals a better conductor of thermal energy than non-metals? This is because they contain free electrons. Okay, and also they have a lattice vibration, but in the choice A, the examiner mentioned the free electrons only. In question number 8, a room is heated by a radiator. The diagram X and Y shows two possible circulations of hot air, which heat the room. Which diagram and reason explain the heating of uh, the room by convection? Look at the two diagrams. The radiator or the air above the radiator has the less density, so it will rise. So diagram X is correct, but diagram Y is wrong because the hot air not falls down, but it rises up. So in the diagram X is correct. Okay, so will it choose A or B? The air density decreases when air is heated, or the air density increases when air is heated. So the air density decreases as the air heated. So in question number 8, we will choose A. Okay, in question number 9, two freezers, X and Y, are identical, except that one has a door opening at the top, and the other has a door opening at the top. Okay, both doors are the same size and are opened for the same amount of time. Which freezer gains the least amount of thermal energy and this time in this time, and why? Okay, look at the two freezers, X and Y. The door at the front receive heat from surroundings by radiation. So it receive more thermal energy than freezer Y, because freezer Y cannot receive thermal energy because the air around the freezer, if you suppose that's hot air, so it will rise up and will not fall down to the freezer. So freezer Y will receive less thermal energy. Okay. So the freezer that gaining least thermal energy, it will be Y. So it will be C or D. The reason that cold air falls while warm air falls, so it will be, okay, X and Y. So it will be C. Question number 10, solid is heated, causing it to expand. Which effect does this have on its mass and on its density? Mass stay the same. The amount of material inside an object stay the same, and the density will decrease because of the expansion, and it will be C. Question number 11. A boy jumps into an indoor swimming pool. He notices that the water appears to get colder as he goes deeper underwater. This is due to convection. Which statement is correct? Cold air is more dense than warm air, so it sinks to the bottom of the pool, and this is a correct statement. Cold air is more dense than warm air, so it will sink down. In question 12, we have an ice cubes and the water between the ice cubes and the heater at the top of the test tube. The ice doesn't melt. What does this demonstrate? This is due to the poor conductivity of water. So water is poor conductor of thermal energy. A copper bar and wooden bar are joined. A piece of paper is wrapped tightly around the joint. The bar is heated strongly at the center for a short time, and the paper goes brown on one side only. Which side goes brown, and what does this show about wood and the copper? As we said before, when the heat is supplied to this point, the paper at the wood side will be brown at first because wood is insulator or bad conductor of heat, but copper good conductor of heat. So the paper at this side will not be brown fast. So brown side will be on the wood because wood is insulator and the copper is conductor. So we will choose D. Question number 14. Why does a balloon filled with hot air rise? This is because cold air is less dense than hot air. No, cold air is more dense than hot air. So this is a correct statement. Cold air is more dense than hot. طبعا heat not rises. The density of the balloon is greater than the density of surroundings. طبعا correct. Incorrect statement. November 2017, question number 15. Which statement about convection currents is correct? Convection currents occurs because when cooled, liquid contract and become more dense. This is a correct statement, but we should read the another statements. Convection currents occurs because when warmed, liquid expand and becomes more dense. No, when liquid expands, it becomes less dense. Convection currents only in liquids? No, in liquids and in gases also. Convection currents only occurs in solid and liquids? No, not occurs in solids. So the first statement is correct. Question number 16. In which type of substance are free electrons involved in the transfer of thermal energy? Liquid, solid, metals only, plastics only. This is metals only because in solids includes metals or non-metals. So in non-metals, there is no free electrons to transfer thermal energy. It exists only in metals. Question 17. In a very cold day, a boy puts one hand on the metal handlebars of his bicycle. He puts the other hand on the rubber hand grip. The metal feels colder than the rubber, although they are both at the same temperature. Why this happens? This is because metal is good conductor of thermal energy. So the metal has a higher melting point, no higher thermal capacity. The metal is better thermal conductor than rubber. Question 18. A student suggested that some uses for containers made from good thermal conductors and for containers made from poor thermal conductors. In which row are both suggested uses correct? Okay, in good thermal conductors, keeping cold liquid at low temperature, this is incorrect. Okay, keeping hot liquid at high temperature, no, because it's good thermal conductor, so it will allow thermal energy to passing through them. Transferring thermal energy quickly from hot liquid, okay. Transferring thermal energy quickly, no, because it's poor thermal conductor. So good thermal conductor transferring thermal energy quickly to a cold liquid, and poor thermal conductor keeping a hot liquid at high temperature. So it will be D. Which process occurs in metals to cause thermal conduction? Electron transfer, no proton transfer in metal, so it will be C, including the electron transfer and also lattice vibration. Question 20. The diagram shows an electric heater being used to heat a beaker of water and identical beaker of oil for several minutes. Temperature of the water and temperature of the oil increases constantly. The rise in the temperature of the oil much greater than that of water. So the temperature of oil is greater than water. They receive the same amount of energy, and this is because oil has lower thermal capacity of water than water. So lower thermal capacity means when the liquid receive a certain amount of energy, the rise in temperature will be higher. But water, because of the large thermal capacity, receive amount of energy and the rise in temperature will be lower than oil. The diagram shows the cross-section of a vacuum flask containing a hot liquid in a cold room. X and Y points on the inside surfaces of the wall of the flask. How thermal energy transferred between X and Y? Between X and Y, there is a vacuum. So the energy transferred in vacuum is by radiation only.